Hello everyone, welcome to this video where we're going to be introducing S-Concrete and its ability to code check your reinforced concrete sections according to the Indian design codes. S-Concrete is a very handy tool for the design and detailing of reinforced concrete sections for beams, columns, and walls. And we're going to actually work through an example or a few little high-level examples here today to introduce you to the interface and the workflow. So I have under the File menu here, I'm going to go to New. And we're going to initialize our new reinforced concrete section project, starting by clicking on the building standard that we'd like to use. So you can see here I'm choosing the Indian steel design or concrete design code rather, the IS 456 code. I can choose the units that I'd like to use, the bar type, and then the member type that we want to use. And again, we can configure this information after the fact as well, but this helps set up our model and initialize it with the parameters we've selected. So I'll click OK. It happens to look very similar to what I have previously shown on the screen. And maybe just for a quick tour of the interface, we can see the sections is actually displayed here in the Visual Editor window. We have at the top of the screen all these different status indicators showing us the performance of our section. And on the left-hand side, we have a number of different sections that are available. So we have beam sections, T, L, and rectangular beams, rectangular columns, circular columns, and a variety of different wall shapes as well. Now, when I'm starting up my section, the first thing I like to do is I like to go to the Edit menu, because there's a lot of different parameters that can be controlled from here. And I can go to the Section dialog here, and I'm going to see information that allows me to control the physical dimensions of the section. So this is a column, a circular column. I just have the diameter that I can control. Right now it's set to 600 millimeters. I have clear cover, so I can see how I can control that as well. In addition to all the different inputs I've set up for my units and design code, I have material properties and so on. I'm not going to make any changes to this, but I'll click OK. And I should note that everything that we've configured in that Edit section dialog to control the physical dimensions of our section can also be controlled from the Visual Editor window as well. It's a very interactive interface. So I can actually left click on the edge of the section and I can drag it in or drag it out. And whenever I make these changes, we actually instantaneously see feedback in the design utilizations shown here. I can also control the reinforcement under the Edit menu. So I'm going to go to the Edit menu, Reinforcing, and we can see here for our column, we have the ability to control the splice type, the bar sizes in the vertical and horizontal directions, as well as the number of bars, whether we want a second layer of bars. So quite a bit of information. I'm using this circular column, so for the horizontal bars, I'm going to maintain this circular configuration of the bars. But you can see that we can control the bar size. So maybe rather than a 32 millimeter diameter bar, I'm going to go down to a 25 diameter bar. I'll click OK. And when I make that change, now I have 8 25 diameter bars. It's showing me the row percentage that I have, as well as the area of steel in the vertical direction. And what you might have noticed change here is the status bars at the top of the screen are now different. So this is showing me now the overall status is unacceptable. I have my shear and torsion utilization, which is the demand capacity ratio for shear and torsion. It's about 35%, so I'm not having any concerns about that right now. And then I have my axial load versus moment utilization, which is equal to 1.146. So I'm about 15% over my capacity for axial load and moment. And we can drill down into this a little bit more. If I go to the results menu, one way we can actually see this, since it is axial load versus moment, is I can look at the N versus M diagram. And I can see this axial load versus moment interaction diagram for my cross section at different theta angles, although we are using a circular section, so it's maybe less relevant here. And I can see that my load combination number 6 is highlighted, and it's showing me that it's exceeding this envelope that I have. Now I can display this for my normal envelope. I can left click on any one single point, and I can see the moment and the axial load at that location. I can also right click and click on normal envelope, and this will show me at the location that I right clicked the compression block depth, the effective depth, how much of my steel is in tension, the strain, and the neutral axis angle as well. And this information can be exported to different formats if we wanted to use that later on. But I'm more concerned with the actual interaction results as well. I might want to look at the report and how this is documented for me. So if we go to the results report, I can see a written report essentially of all the information that goes into the design. So this is showing me the overall summary of the performance. I can see the design code used, the section dimensions and properties, material properties, reinforcement information, the input loads. N versus M results is where I can see my first indication of some sort of violation of the code. And this is showing me governing load combination number 6, which is the same one that showed up in my N versus M diagram. And this is it right here. And we can see that we have a failing utilization, so 1.146 is exceeding 1, demand exceeds capacity. Now I can drill down to the more specific details. If I look at the right-hand side here, I can see my input moment of 447.2 kilonewton meters, which happens to match this value for governing load combination number 6. And my moment capacity is 390.3 kilonewton meters. So that equates to something larger than 1. I can scroll through the rest of the report and I can review what else is included in here. So I can see my shear and torsion utilizations, my tie spacing, my vertical steel area. So beyond just the strength checks that it's performing, it's also performing what I'll call detailing checks that allow us to review if our bars are too close together, if we have too much or too little steel. Those sorts of things are also considered. I'm going to exit out of this, knowing full well that my section is under designed, so overutilized, and we can look at different ways we might want to modify this design. We looked at the edit reinforcing dialog earlier and how we could change the bar sizes. In that scenario, I went from a 32 diameter bar to a 25 millimeter diameter bar. Another option here is to use the interactive interface of S Concrete, and we have this text box or this window that describes our vertical bars, and this actually includes a number of hotkeys that we can manipulate with a mouse click. So it's saying here we have 8 25 millimeter diameter bars in the vertical direction, and if I wanted to add another bar, I can left click on the number 8, and that will add additional bars. So left clicking add steel, right clicking remove steel is kind of the paradigm that I like to describe. I can continue adding bars, and you can see it required 10 25 diameter bars rather to get to a utilization ratio that was less than. Now I could also consider adding a larger bar size rather than 25 millimeter diameter. Go to a 32 millimeter diameter, and you can see when I use 10 32 millimeter diameter bars, it's now less even further. It's about 70% of our capacity. And we can back off on this until we get something that works for our design is perhaps more optimal, and you can see there is a limit to how much we can remove before we get to that failing threshold. The same thing goes in the other direction. So if I wanted to just push this a little further and say, okay, well, I know that 732 diameter bars works, but let's just see if I just keep adding more and more bars, there's got to be a threshold where it's no longer practical. So I just continued adding and adding, and I've gone to 1532 millimeter diameter bars, which I wouldn't advise any of you to do, but it is something that you can play around with and really understand how S Concrete works. And I can see that I'm starting to get this warning. So even though my strength checks are passing, I have relatively low utilizations, I'm getting a warning. And if I go to the results report, I can see more information related to this under the list of messages. This is showing me here the clear spacing between bars doesn't meet the minimum required according to this clause. And I can also see the area of vertical steel provided exceeds the allowable. I can scroll up and I can see the vertical steel area, the maximum, the minimum, and actually what I have. So the maximum, if we use percentages, is 4%, the minimum is 0.8%, and I'm actually at 4.27%. So naturally that will be a concern. I can also see here that it's saying the maximum that it recommends is 14 vertical bars, and I've supplied 15. So if we were to reduce the number of bars, we could probably satisfy both of these warning messages. So I'm just going to reduce this back down to a more reasonable amount, something that's perhaps a little bit more optimally designed. This example was done with a reinforced circular column. And if we look at more details related to this, under the Edit Loads dialog, you may be wondering, well, where did the demands on this section come from? They came from this Loads dialog, which contains a number of different factored load combinations. this loads dialog can actually support up to 32,000 different load combinations. And we can see the conventions used to describe which direction is the positive direction, which direction is the y-axis, z-axis, and so on. And you can see in this example, I'm just using the default loads that come with the default file, and I have 8 different factored load combinations. In this case here, they're all using compression loads. We can tell it's compression because it's negative, and when you look at this schematic, the N arrow describing the axial load is pointing up, which would indicate tension if it were positive. So negative is in compression. And we can copy and paste data in here from Excel. There's ways of bringing it in from SRAM and other analysis software. And of course, we can also write these as concrete files, SCO files, ourselves using CSV or text files, some text editor. We can open them up, and it is a human readable file format. So you can always do that as well. Now, this example that I showed is a circular column. We also support rectangular columns. Right now, when I switch to rectangular columns, it's going to inherit the rebar layouts from my circular column, which may not be practical, but I can change that under Edit, Reinforcing. And here I can see, if we go to the horizontal bars configuration, I can change this to a rectangular bar layout, and I'll just click OK. And if we were to modify the number of bars that were used in this cross-section, it's going to change the tie layout to match the code requirements for a particular application. We also have beams. So here I have beams in the T, L, and rectangular beam shapes. And in this example here, I can see that I have a failing utilization. And I'm using right now a 600 by 500 millimeter rectangular beam. I have top bars, I have stirrups, I have bottom bars, and face steel. And this information can all be described under the Edit Reinforcing dialog. It looks a little bit different for a beam because we have different rebar layouts. So I have a field to describe the top bars, which contains up to five different layers of reinforcement that we can define. And you'll notice that for each layer, each bar input is separated. So we have the ability to define different size bars in each layer. And for just the sake of this example, we've got 2 25 millimeter diameter bars and 3 25 millimeter diameter bars. It would probably be easier to just write 5 25 millimeters plus 0, but we wanted to showcase that you can have different bar sizes in the same field. We can also control our stirrups and our face steel. I do have some face steel, 16 millimeter diameter bars at 180 millimeter spacing. And for our stirrups, we can see they're 12 millimeter diameters at 200 millimeters spacing. I'm actually going to close these stirrups as well. They're currently open. Click OK. And you can see when we made that change, our utilization dropped slightly. But it's still failing, and so we want to understand what we can do to make this axial load versus moment utilization pass. Obviously, we want to go in and review the design report. For the sake of this video, I'm going to keep it brief, however, and I'm going to say that we know that we're failing for moment utilization. So I can go to the Run menu, and I can look at a different way that we can perform design optimization. Rather than manually sequencing the amount of bars that we have and so on, I can go to the Run menu, and I can set up design constraints. And the design constraints here allow me to control different input parameters for my design. In this case here, I might want to go with freezing my bar size. Perhaps I have architectural limitations that limit me from changing the bar size, or the beam size rather, from what it currently is. So I'm going to freeze it at the 600 millimeter depth and 500 millimeter width. But I may want to modify the bar sizes and let S-Concrete's design algorithm come up with new bar size selections. So I'll click OK. And then when I go to the Run menu again, I have this option for automated design. And we can configure how many steps we'd like to perform, whether we want to perform these iterations automatically or step through them one by one. I'm just going to click the Auto button. And you can see S-Concrete's design algorithm is iterating on a solution and coming up with something that might work. It isn't an engineer. I should be clear about that. It doesn't replace an engineer's judgment, so what it comes up with may not necessarily always be the most optimal design, but it is going to try to prioritize giving us utilization ratios that are less than 1. So it's showing us here a table of the inputs before and the inputs after, and what was frozen, what's unchanged, and what's changed. So it's increased the number of top bars, but it's using a smaller bar size. And it's also changed the number of bottom bars, gone up a bar size as well. Now, if we click OK, we can see that we're getting a different looking design, but we're getting a warning. So we can always review that as well. I can go into the results list of messages, and I can see here it's related to my stirrups and link transverse leg spacing exceeding the allowable. And obviously I could make that modification here. It's showing me here my transverse leg spacing, 408 millimeters, and the maximum is 300 millimeters. So something I would want to go in and modify. However, I'm not going to do that right now. The last part I want to introduce is the walls, and we have a variety of different wall shapes. We have I-shaped or rectangular wall shapes that can have zone reinforcement as well as panel reinforcement in between the zones. I have C-shaped walls where we would have more than one panel, and with that, more than two zones as well. I have T-shaped and I have L-shaped sections. With walls, there are a few more inputs that are available. So I can go to the Edit menu, and under Section, I have naturally more dimensions to describe the different facets of the section. I can also go into the Edit Loads dialog, and here I can specify my loads as either sectional loads. As you can see, there's a tab dedicated to sectional loads, which means that those loads are applied to the entire cross-section as per this schematic described here. And I also have panel loads. And the panel loads are a little bit more geared towards, for example, shear design, where we may want to induce a certain amount of shear force, for example, into one or more of our panels. As concrete, we'll look at all these different loads, and for each aspect of the design, it will consider which load combination might be governed. Another unique aspect of walls is that they have, under the reinforcing dialog, the ability to define our zone reinforcement and our panel reinforcement independently of one another. So here you can see under my zone reinforcing tab, I have the ability to control the zones reinforcements for each of my zones. So I have 3 different types of zones. I have the zones at the far end of my wall panels. I have the zones at the shorter end of that extension of my panel. And then I have the zones where those panels meet. And I can control the vertical and tie bar sizes, how many bars I have, how far it extends into the panel. And I have the same information for my panels as well. So in a C-shaped wall, I have 3 different panels. Panel 1 being in between the 2 horizontal panels as we see them in the schematic. I have panel 2 above that and panel 3 on the bottom. And I can control the bar size in the vertical and horizontal directions, as well as the number of curtains. So if I wanted to increase the number of curtains, for example, I could do that here. Now I'm just going to look quickly at the results for my report, or my wall, and I can go to Results Report here, and I can see for this particular wall, I do have a warning, but my utilizations are all less than 1. But if I go to the list of messages, I actually have more than 1 warning, or more than 1 message. So this says the shear reinforcement spacing exceeds the allowable. Panel vertical steel ratio doesn't meet the minimum. Panel horizontal ratio doesn't meet the minimum. And the number of curtains of reinforcement in the panel doesn't meet the minimum required. So some of these might all be able to be addressed by increasing the number of curtains we have in our wall, since that seems to be kind of a recurring theme in those results. But I can see here more information. This is showing me my vertical steel area, or steel ratio, and where I line up according to that. This is also showing me the horizontal steel ratio and then the number of curtains. So if I go back to my Edit, Reinforcing dialog, here I can go to the panel reinforcement dialog here, and for my panel number 1, which is the one that had all those flags, I can click on number of curtains, and I'm going to set this to 2. And maybe I'll also increase the bar size a little bit here. So I'll go to 20 bars, 20 millimeter diameter bars for the horizontal and vertical directions. Click OK. And I still have a warning. I'll go to Results, Report, and I should expect at least some of those messages to have disappeared. And yes, that seems to be the case. Our shear reinforcement spacing exceeds the allowable. I can scroll up here and see that the only thing left now is just there was some shear reinforcement information that needed to be modified. I'm not going to go through that exercise right now, but I do want to point out that all of these reports that we've generated can be exported to HTML or to a Word document. They can be printed. We can also include images in our reports, including the images of our N versus M diagrams. And if we didn't have a lot of S-concrete files, SCO files that we wanted to code check, maybe they represented different components of our structure, different column sizes, different beam sizes of different design groups, we can actually run that in batch as well. So I can go to the Run menu, Batch Processing and Reporting Utility, and I can run all those sections at once and produce a single consolidated report with all the information from the results of all of those different sections all at once. So I hope you found this tutorial useful. We do have lots of other information related to S-Concrete, including dedicated training and other YouTube videos. And if you have any other questions, we'd love to hear from you.